Hiya, this is the second part of the step one question that we looked at last week. Last week, we looked at part one. Now, we are going to look at part two. So, the idea of part one that the question is introducing is that, let's say you have two functions. We know that this is f of x, and this is the minimum value of f of x. This is g of x, and this is the maximum value of g of x. The equation f of x equal to g of x only has a solution when the x value for which f reaches the minimum is the same as the x value for which g reaches a maximum. And I can also add the x's to make it even clearer. So let's see how we can further take this idea to solve part two. Part two. This is a great exam strategy as well, because as you can see, the first part of question two is actually very, very routine. We just want to sketch this function. This is a function that you have seen in IB, quadratic over linear. There are a lot of ways to go about this, but the simplest way, I would say, is by taking derivatives. So, differentiating this guy. And that would give you x squared minus 2x theta divided by x minus theta squared. 2. Y prime is equal to 0 if and only if x squared minus 2x theta is equal to 0, x is equal to 0, or x is equal to 2 theta. Step 3. Now we need to find the intervals on which the function is increasing or decreasing. So let's just find the intervals on which it is increasing. Y prime is greater than 0 if and only if x squared minus 2x theta is positive, because the denominator is always greater or equal to 0. Solving this quadratic inequality is trivial. We want to solve this inequality. From the question, we know that theta is positive. It's between 0 and pi. That means that 2 theta is positive, and we can then sketch our quadratic function. Bang. 0, 2 theta. We are looking for the intervals on which it is positive. So in other words, x is less than 0, or x is greater than 2 theta. So that gives us a lot of information about the shape of the curve. If we are to quickly sketch it out, let's say this is theta. We know the function has a maximum, has an extrema at x equals to 0. At x equals to 0, y is equal to 0. If x is equal to 2 theta, y is equal to 4 theta. I should have used a different scale, eh? If you want to make the sketch even better, you must also find the equation of the slant asymptote. To find the equation of a slant asymptote, we are going to do the long division. So let's start off by adding and subtracting x theta, because that would give us the x value, plus x theta divided by x minus theta. So y equals to x plus theta is going to be the slant asymptote in this case. So this would be the slant asymptote. Please actually use a ruler for the exam. And we can fill in the remaining details. It is increasing until 0, it's decreasing. It is decreasing until 2 pi, then 2 theta, then increasing. So that would be the curve. Part 2. By considering the numerator and denominator separately, show the inequality. So we're asked to show that sine squared of theta cos squared of x divided by 1 minus cos squared of theta sine squared of x is less than or equal to 1. So let's look at the numerator and the denominator separately. Looking at the numerator, we need to find a way to obtain the same expression in the denominator so that we can do the comparison. So we need to find a way to make cos squared theta sine squared of x show up in the denominator. Sine squared of theta, that is 1 minus cos squared of theta. Cos squared of x, that is 1 minus sine squared of x. Expand and simplify, you will get this. Therefore, sine squared of theta cos squared of x divided by 1 minus cos squared of theta sine squared of x is equal to 1 plus this positive term minus the negative term. It is 1 plus in the denominator. Apologies. Doing log division, we'll get 1 minus this term. I'm sure we can all explain why this value is less than or equal to 1. This is because cos squared of theta greater or equal to 0. Sine squared of x greater or equal to 0. Therefore, cos squared of theta plus sine squared of x greater or equal to 0. 1 plus cos squared of theta sine squared of theta greater or equal to 0. Actually, this has to be greater than 0. Therefore, the quotient is also greater or equal to 0. So we have 1 minus a positive number has to be less than or equal to 1. Done. Third part of the question. Hence determine the values of x and theta that satisfy the equation. Sure. What have we shown above? Look at the left-hand side. We have looked at the curve x squared divided by x minus theta. We showed that the minimum value is 4 pi, or 4 theta. Therefore, we know that x squared divided by 4 theta times x minus theta is greater or equal to, well, 4 theta divided by 4 theta, or 1. On the other hand, we just showed also that sine squared theta cos squared x divided by 1 plus cos squared of theta sine squared of x is less than or equal to 1. left hand side is equal to right hand side if and only if they're both equal to 1. So let me see if there is a nice way to solve the question. The left hand side, this is equal to 1 if and only if x is equal to 2 theta. For the right hand side, this is equal to 1 if and only if cos squared of theta plus sine squared of x is equal to 0. Cos squared of theta greater or equal to 0. Sine squared of x greater or equal to 0. This is true if and only if cos of theta is equal to 0 and sine of x is equal to 0. Theta is equal to, therefore, pi by 2, 3 pi by 2. X is equal to 0, pi, 2 pi, and so on. Furthermore, furthermore, x is equal to 2 theta. So if theta is pi by 2, x is equal to pi. We can accept that. If theta is 3 pi by 2, it already exceeds the range theta between 0 and pi that we're given in the question. Therefore, the only solution to this equation is this. When theta is pi by 2, x is equal to pi, and there are no other solutions to the equation. And this is the end of a lovely question combining way too many topics written by STEP examiners. I hope you enjoyed it, and see you in the next video.